All right. So we have learned a few uh, dplyr functions already, right? Okay. So any question up to this point of time?
Professor,
Yes.
so is sort function and arrange function the same?
Sort is not, no, they are not quite the same. When you use sort, you can only sort a vector, right? You cannot sort a data frame. You remember? If you sort, you do sort, you can sort a column, isn't it? But you cannot sort the entire data frame, isn't it? Arrange function is to arrange a data frame by the content of a column, right? But if you sort the column, actually, it just reorder the vector, right? It did not reorder the column within the data frame. You get my point?
So we can only rearrange one column in the whole data frame if we use sort function.
Yeah, if you are using sort, you are actually kind of just reorder the content of a column. But you cannot do that, right? You want to reorder the data. You want to reorder the data by a column, but you actually want to reorder the rows, right? Instead of just reorder the function. So arrange is much useful than sort when you are doing data frame, right?
So if we use the arrange function, can we give up the sort function?
Give up. Well, sometimes you will still want to use sort, right? Sometimes you will have a vector and you want to sort the vector, right?
We can still use arrange function to sort the vector, right?
I don't think arrange can be applied to a vector. If you want to use arrange, the data object has to be data frame or table, right? So the function they act on different type of data structure.
And what about order function?
The order, uh, the order actually return the index, right? As I mentioned earlier, right? Order is kind of like it do not give back the original content, okay? It just produce an index so you can use to reorder something else, right? So there are three different uh, function and used in different way, okay? Well, it's it's reasonable to like get confused, but
So professor, can order function replace arrange function?
yes, you can. You can use as you can see that this function is the same as this function, right? Okay, but if you want to use order, uh, the syntax is much more complicated, right? It's kind of like you must be very careful, otherwise it's very easy to make mistake. But use arrange is quite intuitive, right? Especially when you are dealing with data frame. Okay, the sort and order most likely you are using in vector. Okay, you do not use them in data frame. Okay, when you want to use in when you want to reorder a data frame, arrange is the best choice, right? But sometimes your data is not a data frame, right? Sometimes the data is like a vector or something. Then the function is still required. Yeah.
No, how about list?
Sorry.
If we have a list,
Basically, you cannot do order or sort on list. You cannot.
But arrange, we can use arrange.
No. Arrange apply to data frame. They do not apply to list.
Any other type of
Yeah.
data, only data.
Yeah, only in data frame, only in table. Yeah. The function in dplyr, they only apply to table. Okay. If you try to apply them to some other data structure, you will return the error. Okay. Anything? Any more question? Okay, let's continue. Now, the Unit 5A section 2 is called data aggregation, which means that we want to do some like summary statistics of the data. Okay. The first function I want to introduce is called count. Count is very useful, right? Its function is similar to table and dplyr, as you will see. Okay. So if D is our table, right? It's our table, and if I like apply count to D, and it will basically just return the number of rows within D, right? Count a table is to count the number of rows in the table, okay? But if I count it this way, I count D and then state. Take a look at the outcome. What is that? I use count, and D is a table, right? And then I put one more argument, state. State is actually one of the column within D, right? So what does it mean?
That counts the number of states.
No, they are not counting the number of states. Alabama is a state. So what is this 67?
Alabama is there in the data 67 times.
Yes. Correct. It means that within the state column, Alabama is repeated 67 times, right? Alaska is repeated 28 times, which implies that Alabama has 67 county, right? And Alaska only have 28. Arizona only have 15 county. Okay? Is that true? That Alabama only have 15 county? Okay. Well, whatever. It's the data, right? It's within this data is the way. So it actually, there's a function, right? Very similar to this. There's a function. Is that anyone still remember that function? That you use a lot in your homework assignment last week. Summary, t-apply? No? No. L-apply? No. Table, yeah, it's look like table, isn't it? Right? When you do table, so I think you get a prize, right? it looks like table very much, right? See if I do table, what do I have? Right? If I do table, it basically do the same thing, right? But the format of the output of table is actually a vector, right? It output a vector, right? However, if you do it in count, see, as I told you, all of the function in dplyr, the output is a table, okay? So it's not a vector. It's not a simple vector, right? It is a table, okay? So because it is a table, so you can like see pipe it. You can process it later on, right? In dplyr, within dplyr, isn't it? Right. So make it more convenient. Yeah. Actually, you can put one more column in the count. See, if I do state and also metro, okay, then see, you can see that Alabama has 29 county in metro and 38 county in non-metro, right? Alaska has metro area. Okay, you have 3 county in metro area, and then 25 county in non-metro area, right? So you actually can put more than one column name in the count. Okay. So so if you count it like every combination, every unique combination of these 2 columns, you count the number of columns. Okay. Sorry, count the number of rows. And then now instead of just counting the number of county, right? You can actually do it. You can add a argument called weight, okay, and you can also add an argument called sort. Okay, let's see what would happen when we add this. Right? So when you put the WT, it actually will not count. If I do not put WT, right, it will only count the number of county in California, right? Okay, but if I put a weight here, it will actually sum the population in California. Okay, so this looks like dplyr, right? Isn't it? It is like kind of like sum the population by state. Right? Sum the population by state. Okay? So in count, you want to sum the population by state. You put the population within the argument weight. Okay? WT. Okay? And then in this way you can like see very easily sum up all of the population in every state. Okay, and you can sort the result, okay, all in one function. Okay, so this count function is kind of like a combo function. You can see it that way, right? You do a dplyr and do a sort, right? All in one function call. See that? See that? Okay, so it's very convenient, right? Count is super convenient, and when you use dplyr, you use it a lot. Okay. Okay, so you can use it in a way that we are using table. You can use it in a way as we are using dplyr. Okay, and you can also combine the sorting function within the same function. So count is a very, very, very sophisticated combo function that you will use very often. Now, after count, the second aggregation function that we want to learn is called summarize. Okay. Well, you can see the function of summarize by example. It's most easy. If I use this D object and I want to summarize the total population, right? So when I summarize two. I summarize two columns, right? The first column is called total population, and it's the sum of population. As you can see that, this is total population, and this is the average population. Okay, in every county, per county, average population per county, and this is the total population of all of the county, right? So unlike the the mutate function, right? The summary function is actually, it will summarize the entire data, right? It work on the vertical direction, right? Summarize the data in the vertical direction. So you can define the name, and then you can put either a function call or some mathematical calculation. But whatever you want to do, this expression must return a single value, right? Because you are doing summary, right? So it has to return a single value, isn't it? This expression must be evaluated into a single value, right? And then you can give it a name, right? Put that into a summary. So you can summary a lot of things in one function call in this manner. See that? Okay. Okay. So summary is just do the summary function in the vertical direction. Now, usually you can see if we do not do it this way, we can also do this, right? We can do some depopulation, mean depopulation. But if you do it that way, it will actually have two separate values, right? When you do summary, the benefit is that it will put all of this summary in a single data frame, right? So it make your data processing easier, right? Later on. Okay. Now, usually, this summary function will work with group by. Okay. Now let's take a look at this. Okay. Go back to. Now let's for now, if I group by state before doing summary, okay? Sorry. In this code chunk, I do not group by anything, right? So when you do not group by anything, it actually summary every row, right? But if you group by state, the summary will be due on a per state basis. Okay, so let me do this. Let me do this. When I execute these two things, see? Now the Alabama, right? And this is the total population within Alabama, the average population within Alabama. See that? So when you change, when you first of all, when you put a table into a group by, as you can see that the table by itself, it's simply a table, right? Okay, a table of a 3138 column times 40. Okay, but if I put a group by, now look at here, right? Look at here carefully. When the pipe run to here, you'll see a group structure. See? The table will have a group structure within the table. Okay? And when the table have a group structure, the summary function would operate in a group by group fashion. Okay? So because they are group by state, right? They are 50 state. So right now the summary is summary by state. You see that? And that is very, very useful in business analytics. Okay? Right? We will see that later on. Okay? In the real data. Eh? Yes? Sorry?
The average in this code, how do we get the average? Like, not the formula, but what is it? It's population divided by what? Because the average is different for every state. How is that possible?
No. they are not the same. Are they the same?
If it's average, then the average should be same for everyone because it's the mean of the whole population. How is the average?
What do you mean? By when we do this, right?
Yes.
We will have
So is it the average population of the one county in the state of Alabama?
no. It's the average population of all of the county within Alabama.
Oh, got it.
You get that? Because as I told you that when you have this group structure, right, the summary would operate in within the group. So now, and the first group is Alabama, right? Okay. So let me add one thing. Okay. And within dplyr there's a function called n, okay, simply n, okay. So and in this case it's the number of counties, okay. So Alabama has like California has like 58 counties, right, and its total population is like this. The average population per county in California, right, is things like that. Get it? Okay. So when you have group by and summary, it's very, very powerful. See that? Okay. So you can do the kind of like if you want to do this in t-apply, it would be very, very cumbersome, right? You need to do one t-apply here, one t-apply here, right? One t-apply here. So it's like you need to do a lot of t-apply, and then you if you want to put that into the same data structure, you need to like combine them with a column bind, something like that, right? So it's a lot easier to do a group operation within dplyr. Yeah.
So the group operation naturally knows that once we get the total population, it has to pick counties for average. Because we never mentioned that we want the average of counties. It just naturally picks the county subset.
Actually, because our data, every row of our data is a county, right? You got that? So it imply the county things is actually implied within the data structure already.
But how do we know that county is the main variable of our data set?
You need to know it by yourself, right? So
How, like when you ask in the beginning of the class,
see, when you gather the data, you need to know.
no, of course. But when in the beginning of the class you ask to look at the data structure and then guess the main variable, because
It's-
there's so many rows.
How do you know that it's the county, right? You need to know it, right? Because someone give you the data.
Got it.
When you get the data, you should already know that, right? This is not a thing that you look into the data and then guess, right? This is the thing that when you have the data, and you should already know this, right? You should already know that each row represents a county, right? And each column represents a characteristic of a county, right? This thing you need to know, right? Okay, so now we see the power of group by summary, right? Let's do one more thing. I told you that you can actually group by more than one column, right? Okay? For example, here we group by state and then metro. Okay? Let's see what will happen. When you group by state and metro, now you see that in Alabama, the metro area, this is total population in Alabama metro area. This is the total population in Alabama non-metro area. You see that? Okay. So when you have, actually you can have 3, 4, 5 if you want to. Okay. You can group by a lot of variables, a lot of columns. Okay. And every unique combination of this grouping variable, every unique combination of it, of this variable will become a group. Okay. So let's see. If we do it like group by state and metro, see, you have a group structure, right? See that? Okay. Now we have 97 group. Okay. Which means that there are 3 states do not have non-metro or do not have metro. Okay. All right. So if I do it this way, then after I do the summary, let's see what happened. After I do the summary, I actually have 97 column. Sorry, 97 row. Right? Okay. See that? Okay. 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 Now, there's one more thing that for now, let's take this away for easier. See this? Okay. These are the two grouping variable, right? State and metro, they are the grouping variable. And these two things are the summary variables, right? Now, what is this groups means, right? Okay. If you let me take it away and see. Now take a look at here carefully, okay? I want you to see the difference, okay? If I do not use this, okay, and take a look at here, okay, there will be a warning message, like, okay, and the output would still have a group inside, okay. If I do not drop the groups, okay, the summary only take away one group, okay. If you have 2 grouping variable, after summary, the first group variable would remain inside the data structure, okay. Every summary only take away one of the grouping variable, okay. So if you have 2 grouping variable, then at the end you will actually have a table of 97 row, but this 97 row are still in 50 group by state, okay. Now if for some reason you don't want to have this grouping structure within your outcome, okay, you need to drop the groups explicitly, okay. See, I dropped the group, right? So I no longer see the warning message, and I do not have an internal, I should say, non-necessary grouping internal structure with me, okay? So when you are using group by, be careful, right? If you group by something and for more than one variable, then there would be some remaining grouping structure within the data, okay? And that would cause trouble later on, maybe, okay? So it's a good habit, right? Try to drop the remaining groups if they are not useful, okay? We will go into this point. This is a little bit complicated, but so far, the first time you will see that you will feel a little bit confused. But when you are processing data, when something strange happens, right? When you are using dplyr, when something very strange happens, usually it is because that there are some hidden grouping structure within your data and you do not know this. Okay, so be careful about that. Actually, when you do when you only have one group, the summary will take the grouping variable away automatically. Okay, so you can see that. If you only have one grouping variable, the grouping variable will be taken out by summary automatically. But when you have more than one grouping variable, you need to be careful, okay? Because if you do not use this that group equal to drop within summary, the outcome would would have the internal hidden grouping structure remained within the data, and that could cause trouble later on. Okay. Now, next function that I would like to introduce is called the top n. It is also a very useful function, and see, if I want to see the from D1, I want to choose the 3 county with the largest population, right? So D1 is here, right? D1 is like 3138 county, 4 column, right? And within this 3138, I would like to fill out the top 3 county with the largest population. Okay, that's what I do. So this top n is like quite intuitive, right? With example. See, if I want to see the top 10, unemployment, right? See, this is the top 10 employment. Okay. And usually, if I do this, I would like to see. I would like to arrange it by decreasing unemployment, right? So you can see that this is the top 10 things, right? Now, if I do a group by before doing top n, what will happen? See now, within every state, right? You will choose the 3 county with the largest population. See that? See, here I do not use the in this example, I do not use group by, right? Okay, so you look into this D1 and choose it. Choose the 3 county with the largest population. But now I use group by, right? So as I told you that most of the function in dplyr, when they are internal group, they act on the group. Okay, so for every state, for example, for Alabama state, it takes out the 3 county with the largest population. Okay, and they'll do the same thing for Alaska, Arizona, and so on. Got it? Right? So group by actually imports internal grouping structure within the table. Okay, and when your table have this grouping structure, all of the function of dplyr would operate on a per group basis. See that? Okay, And in business analytics, from time to time, we will need to do this. Okay, and we will do this a lot. Right? Okay. Okay? Now let's go to section 3 of this notebook. Now, in section 3, there are some accessory, assisting function to make it easier. See, R is a lazy function, right? R is a lazy language, so to make it so you can type things in a more convenient way. Okay. So, for example, when we are doing select, okay, you can select it by by name, right? Okay. But sometimes you want to select a range of columns. For example, in D, if I want to select the if I want to select from drive to work at home, so this is drive, this is work at home, right? If I want to select 1, 2, 3, 4, 5, 6, 7, right? This is 6, 7 column. Then you can write this way. Right, from drive to work at home. Then you will actually pull out from drive to work at home. See that? So make it easier, right? And you can also use if you select it this way, you will select all of the column with the column name, all of the column with the work in the column name, like work at home, private work, public work, family work, right? As long as the column name has this phrase, work, has this pattern, work, will be selected. Right? Or you can select the columns that start with something or end with something or contain something, right? So to make select easier, right? That's the thing, right? Or you can use the minus select, okay? For example, if I want to exclude all of the column with work, okay? I want to exclude this 4 column with work, related to work, okay? So I can do this. So after I removing this minus sign is called remove, right? So after I remove this column, the number of column is 36, right? Original is 40, right? So after I exclude the 4 column that contains work, okay, I will have 36 remaining. Okay. So there's another function called rename. Actually, every flower in this notebook, every flower represents a function. Okay, so sometimes you would like to rename a column. For example, if unemployment is too lengthy, right? So you want to rename it to, okay. So after rename, originally this column is called unemployment, right? Now the column name is renamed to unemployed. So it's quite straightforward. Usually you can use select to reposition and rename. For example, if I want to change the order of the column, or I can do it this way, right? Within the select command, you can actually change the order of column, okay? And you can also change the name of a column. See that? Okay? So within select, you can actually change the order of the column. You can also change the name of the column. Uh, there's a function called transmute. Okay, it's kind of a combination of select and mutate. Okay. Um, when we do select, okay, we are select like separate function by name, right? But when we do mutate, we are actually calculating a new column, right? Right? You select a few column. When you mutate, you can calculate some new column, okay? And sometimes you want to combine the two, okay? And in this way, in this situation, you can use transmute. So in transmute, you can select the existing function, and you can also calculate a new. You can select the existing column, and you can calculate the new column, right? By defining new column, right? By calculating, by computing the existing column, you can define new column. So you can, in select, you cannot define new column, right? Okay. But in transmute, you can. Okay. See that? So actually, you can do it in 2 steps, right? You can select and then mutate. Okay. But this transmute is like, it let you, like, it's a shortcut, right? It let you like combine the 2 things within a single function. Okay. So basically, this is these are the function that we would use, right? In dplyr, most of the time, okay. But dplyr is actually a quite complicated package, as you can see here. Actually, I if you look into the internet, there's a thing called dplyr cheat sheet. Okay, so it would actually explain all of the function in dplyr. But for beginner, actually, I do not recommend you to like doing this cheat sheet, learning everything at one shot. Okay, that would make it very confused, right? For beginner, I would recommend that you learn the function that I already cover in today's class. Okay, start with them. Okay, and get familiar with them, right? And when you have enough of experience with this core functions, with this set of core functions, then you learn more. Okay. Actually, in our course, very seldom we will use. You will need to look into this cheat sheet to get more function. What I have just mentioned in this notebook should be good enough most of the time. Okay? Question? No? If no question, let's also take a look at the next notebook.
Sorry, it's not related to this, but do we have a midterm?
Do you have what?
A midterm exam?
No, we don't have a midterm. I will explain that later. Okay? Later in the course. Yeah?
Professor, I would like to ask if we can use the function like contains, start with or end with other functions. For example, like subset, is this possible? Or we can only use the contains and with start with.
Usually you only use them within select. Okay? Maybe you can also use it in transmute. But I did not try it myself. You can try it and see how it works. Usually it only works within select. Okay, you cannot use the content start with, end with in other. It didn't make sense to use them in other situation today. I don't think they will work in other. Some may, some function may. When they make sense, you can try to use. Okay. But for me, I usually only use them in select. Okay. So we have one more notebook left, right? It's the group operation. Let me open that first. Now, we already mentioned about group by and summary, right? Earlier, and actually, group by not only can work with summary, sometimes you will do group by with mutate, okay? And when you use group by with mutate, you need to use it carefully, and that's what I would try to cover in this notebook, okay? So usually you will use group by with summary, okay? But sometimes you will actually use group by with mutate, okay? And when you use group by with summary, you will sometimes use more than one grouping variable, right? So this group operation need to be explained a little bit, a little more, okay? That's what I want to cover next hour, okay? And after we and I would like to reserve some time in our next hour, and I want to give you our midterm data set. Okay, we do not have a midterm examination, right? But we do have some midterm group presentation. Okay, so in order to do our midterm presentation, you need to have the data, right? So I'll give you the data, and because next week we do not have class, right? Next week is off, right? So I want you to like use this group by, this dplyr operation to process the data that I give you. Okay?
Will all groups have the same data set, or will we have?
All groups have the same data set.
But then how will our presentation be different?
Well, you will see. See, data is the same, right? But when we explore the data, you will see different insight, right? And that's the point of business analytics, right? You have the data there, and you want to dig out the insight from the data. And we'll spend a few weeks before the midterm teach you how to extract useful information of real business data, okay? Using dplyr and some plotting functionality. Using dplyr to extract information and present the data in some interactive plotting. Okay, that's what we want to do before midterm. Okay, let's have a break and be back at 11:10. Okay, be punctual. Okay.